Hey everyone, welcome back to The Explainer. Today, we're going to completely unpack a concept that's, honestly, the absolute backbone of modern software development. We're looking at exactly how version control systems work right under the hood. All right, let's jump right into this. Picture this. Pure chaos. A marketing team is managing dozens of assets, right? And suddenly someone accidentally saves over the master document for the main ad campaign. Just like that. Hours of highly nuanced, painstaking edits, poof, gone in a literal instant. Without version control, that kind of scenario leads to massive confusion. You're dealing with overwritten work, lost changes, and zero ability to just hit undo. But if you inject version control into the mix, it's a real game changer. You get immediate organization, you can track changes, collaborate safely at the exact same time, and, best of all, easily roll back to a previous working version. Okay, moving into section 1. Let's meet your project time machine and talk about rewinding those frustrating mistakes. I love this quote because you really can think of version control as a literal time machine for your projects. This isn't just about hitting save. It's about meticulously tracking your changes over time. Say you made a catastrophic error on Tuesday. No big deal. Just hop in the time machine and restore the file to exactly how it looked on Monday afternoon. So, formally speaking, version control is just a system that records changes to a file or a whole set of files over time. It lets you recall specific versions later on. It essentially serves as your absolute insurance policy against data loss. Without it, managing even a tiny project can quickly descend into conflicting changes and endless headaches. Which brings us to section 2, how version control works, right under the hood. Now that we know what it is, how does it actually track your files without creating a million messy duplicate copies labeled final_v2? Well, the physical process is actually incredibly elegant. First, you create a repository, or a repo. Think of that as your master storage vault for all your files and their entire history. Then, as you make changes, you periodically make what's called a commit. A commit basically takes a perfect, high-fidelity snapshot of your entire project at that exact second. Now, here's what's really interesting about this slide. The system is incredibly efficient because it doesn't actually save a complete new copy every time you commit. Actually, scratch that. It tracks only the differences, the deltas between your snapshots. It basically just asks, okay, what specifically changed from point A to point B? And this builds a highly efficient, complete audit trail of exactly what changed, who changed it, and why. To put that into perspective, imagine you decide to make a few quick changes to a CSS file just to tweak your personal website's colors. But oops, you accidentally introduce a bug that completely breaks the entire layout. The text is overlapping, the images are massive, the whole shebang is entirely unreadable. So what do? Well, relying on a manual fix means you're desperately digging through lines of code, trying to remember exactly what you changed, and basically just guessing how to put it back together. But with a version control rollback, you just tell the system to instantly revert your CSS file to the previous working commit. Boom, fixed in seconds. This makes deploying new versions and recovering from those inevitable mistakes incredibly low stress. Let's shift our focus to section 3, branching out and fearless collaboration. So this fearless collaboration happens through a really clever concept called branching. You have your main branch, which is the stable working version of your project. But let's say a web developer wants to try out a brand new JavaScript framework. Instead of messing with the stable build, they just create an isolated experiment branch. They can build, tinker, and break things over there without posing any risk whatsoever to the main site. The workflow here is beautifully simple. Step 1, branch off. Step 2, experiment in total isolation. And step 3, if it works, seamlessly merge those successful changes back into the main branch. And if the experiment completely fails, you simply delete the branch and pretend it never happened. So the crucial point is that whether you're a developer coding an app or a writer drafting a book chapter, you can experiment safely and automatically merge your changes when you're ready. Moving right along to section 4, real-world version control. And spoiler alert, it's not just for code. Let's move beyond just software engineering for a second, because this time machine is universally valuable. Version control goes way beyond just source code. We're talking configuration files that dictate how software runs, small image and media assets, raw text documents, documentation, you name it. Literally, if you collaborate digitally and your files go through revisions, this is an absolute essential skill. As you'll see here, the real-world applications across different industries are incredibly diverse. Sure, software devs use it to manage code, but technical writers?
They use it to meticulously track revisions on vast libraries of manuals. Game developers use it to manage complex assets and design documents alongside their code. Even scientists use version control to rigorously track changes to critical research data. It guarantees total accuracy and an unbroken audit trail for their findings.
So, we've seen how version control acts as a project time machine and enables this fearless collaboration. But what happens when a massive organization completely fails to use this fundamental tool? Well, the results are often catastrophic. We're going to explore exactly what that fallout looks like in our upcoming explainer on the Project Phoenix case study, where we'll also take a deep dive into Git and distributed systems. Until then, ask yourself, couldn't your projects use a time machine? Thanks for joining me on this series explainer.